Hi, in this video we're going to look at the role of a database administrator. So this is going to be the person or people who are in charge of making sure the database works properly all the time. In a large company, you may find that a database administrator is a full-time job, maybe even as part of a team. If you have need of an extremely big database or sets of database, if you think of someone like Amazon or one of the big stores, are likely to have a large number of databases behind the scenes, and they'll need people to make sure that they're working okay. So things that they could do, but not limited to, obviously database performance, you've got integrity, security, development planning, and troubleshooting, and we're just going to explore each one of those. So first of all, look at performance, which is going to be the speed and reliability of the database. So what you want is to ensure that the database works all the time whenever people want to, and that whenever they could potentially need to access it, they're able to do so. So if you think about a larger company, they may have hundreds of people accessing a database at any given point, and they'll need to be able to ensure that they're able to do that. Whereas if you think about maybe a smaller piece of software like Access, actually that's limited to only a couple of hundred people at any given point, so you're likely to need one of the more expensive pieces of software like SQL Server and so on. You also want to ensure the database runs to its optimal level. People get very frustrated if you are trying to use a database and it's running very slowly. Obviously that will ensure that their jobs are not done as effectively as what they could otherwise be, which is annoying for everybody, really. Obviously there are other issues behind that. So for example, if you're a database administrator but actually your hardware on the machine is not very good, boy, you're going to be limited with what you can do. You're going to need to make sure that your database is really refined and really kind of working as best as it can. Ultimately, it might be out of your control whether or not the database is running as well as it can, but you must do what you can ultimately if that's what you're employed to do. So the next one we're looking at is going to be the integrity of the database. So this is accuracy and consistency stored within of data stored within a database. So ultimately, a database is only as good as the information that goes into the database. And if the database is accepting data that falls outside of the normal boundaries that you would expect, then the actual data going in is not going to be particularly worthwhile. So think about a date of birth, for example. What happens if the database is accepting values which it shouldn't? So let's think about the longest month is 31 days. So what happens if it accepts a date which is outside of that, 40 or 45 or even a naught? Those simply wouldn't exist. And also, you could be doing things like validation verification to ensure that it's meeting the ranges that you're expecting. So ultimately, you can only restrict data so much. Especially if you're thinking about things like names, some names have various different characters within them. You can specify the maximum length that they can be, but it's things like numbers and special characters. Some names have numbers and some names have special characters, so you would struggle to really kind of tie that down. But ultimately, you got to do what you can. And the idea here is, let's say, for example, if you have gender. Okay, so gender generally only has a handful of values that a person can ultimately choose. So what you don't want to see is lots of different values going all the way down. You want the same value to be used if somebody is entering male or female or other or whatever value you choose to accept. And that's obviously very important, because then if someone's doing a search for that, they can find it easier. And also you could potentially only need to store that item once within the database, and then you use it many times, which is something we look to encourage within a relational database. Accuracy as much as possible. So you want to ensure that the data that is held within the database is as accurate as possible. So if there is the opportunity to restrict the type of data that is being accepted, then you want to be doing that for either validation or verification, because then the data is more likely to be accurate. You would want to check over the database, maybe double, triple check it once the data's gone in to make sure it's okay. You're going to be wanting to ensure with customers, if that's what you're dealing with, that the data that you store about them is accurate, and so on. Normalization is we don't want repeating data. So what we don't want is to have somebody's details stored within the database multiple times, because then if they do need to update their data, the company would update one of them, and then the others potentially wouldn't be updated, and therefore you would have multiple sets of data that would be wrong, and that isn't good. Obviously, the more times you store somebody's data, the more space it's going to take up on your servers, which, if it's only a small database, may not particularly be a massive issue. But if you have a large database, that is obviously going to be an issue. Think of somebody like the Amazons of this world. If they have everybody's data stored multiple different times, that could be horrendous. The space that would take up is frightening, really. Okay, so security is obviously a massive issue these days. So you've got to ensure that your data is secure from potential threats. And what we have here is and a couple of different things, really. So the data could be stolen by someone. So that somebody could potentially access the data and then take it away. They could change the data. I think I meant to change one of these words, by the way. So the data could be changed, or it could be I can't think of the right word. It could be at risk from a natural threat. So if you think about some of the places that around the world that may be at risk of things like earthquakes and fires and so on, there's a number of different places within the UK that have had issues with flooding recently. All of those are natural threats, and you, as a database administrator, you need to be able to help protect as much as possible. So you're going to be looking at things like your passwords, you're going to be looking at things like backups, you're going to be looking at maybe key logging, you're definitely going to be looking at specified levels of access, because what you don't want are all your employees being able to access everything on the machine. Generally, within a company of any size, you would have various different levels of access. And let's say, for example, if I'll use a college as an example, when you log in as a student, you have access to certain things. So, you could have access to your details, attendance records, your progress tracker, and so on. Your teachers will have more accessibility. So, you, as a teacher, we're able to generally access information about any student within the education environment. Now, we can't access any data about other members of staff, however. That would be something which somebody like HR might need, but even they, you would imagine, would have some kind of specified level of access, because ultimately you probably wouldn't need to know every little bit about every member of staff, especially things like bank details and so on. You just wouldn't need it. Planning and development. Obviously, within IT, things get updated all the time, so you're going to have to plan for that, and also think about how things would get upgraded. It's not quite as simple as it would sound, because generally when things do get updated, it's quite hard to get them right first time, and things like backlashes can be quite important in that regard, because if you change the way something looks and works, and the people who use it don't like it, then what you don't want is for them to stop using it. If you think websites are quite a common example, websites such as Facebook have changed commonly over the course of the last decade or so, and every time they do, people get very irate about it in general, until it all calms down and everybody gets used to it. Now, within a business environment, something like a database, that still applies, because ultimately people are going to be using it all the time. If it's used for their job and it takes a while for them to get used to it, then that's going to affect their productivity. It's not good. Ultimately, we want people to be working to their maximum levels of efficiency. We may need to provide training for them if it's quite different. If we think about some of the examples of software looking quite radically different to what it did previously, especially with the newer versions of Office. Now, not everybody uses Office, but enough people do for it to be an issue if it gets updated. Generally, companies will wait a few months before migrating their systems from one suite of programs to a different one, purely to make sure that any issues have been ironed out as much as possible, or if it's totally incompatible, they just won't move it at all. But ultimately, the idea with upgrading is that it does contain newer and better features. So you have got to trade off against that as well. So it's an important thing to bear in mind. You got to plan it in terms of if it is. I'll use the college as an example again. If it's at the college, then these things need to be implemented at a time when everybody's not teaching. Otherwise, what will happen is teachers cannot do their jobs, which obviously have a huge impact. Whether or not it's taken into consideration, who knows? But that's the theory behind it anyway. Troubleshooting is the last thing to talk about. So you've got a couple of issues here, such as if things go wrong, finding and fixing the fault. So if there is an issue with the program behind the scenes, you have to go and find and fix the fault. That's a pretty straightforward thing ultimately. There are lots of jobs dedicated to that sort of thing. You could also have an issue whereby users might have a problem with the database, but there isn't an issue with the database. The issue is with the person using the database, in which case you need to go and help and potentially train them up so that they can be more efficient with it and be able to learn how to use the database more effectively. You also want to spot common patterns with whatever issues come up with, because ultimately if there are common issues, you want to be able to go and fix them before they become major issues, and that's where you log faults, because ultimately if you have a team of say 5 people in your troubleshooting team, and each one of those 5 people receive a issue and they don't log it, well, if that issue is the same, well, actually you've had the issue 5 times and it needs to be fixed. But if nobody logs it, then there's no way to know about it. Each individual person might have just had it once. In which case, if that occurs, you just kind of think, well, these things happen, and you tend to prioritize other stuff. However, if it's logged in a system, then you can tell that you've had 5 or however many instances of something going wrong, and it needs to be fixed, and it'll probably need to be a priority if it's happened 5 times, but that's just an example. So that's the role of the database administrator. So there are entire jobs out there where people are hired to fulfill the role of database administrator. It is a very important role, but I would imagine it's probably not the most creative role. But it'd be very good for someone that's quite analytical. Anyway, I'm not trying to sell the job, but thank you for watching, and I will see you soon. Thank you. Bye bye.